Okay, now we're looking at page 91 of your workbook. This is part 2 of section 7.1. 7.1.3, a binomial as the greatest common factor. Example 7.6. So for this one, a greatest common factor, again, is any factor that has, when it's raised up, you have it common, and you're taking the lowest exponent on it. So here we have 2y minus 7, we see it twice here. Okay, so we are going to, let me read this whole thing first. We're going to pick this apart. 5x times quantity 2y minus 7 plus 6y times quantity 2y minus 7. So that's common to both of these terms. So again, just like I did with that 4 in the previous video, I just pull that out. That's my GCF. So identify my GCF, and that is 2y minus 7. And then we always want GCF times the rest, right? Or what's left, I should say, right? What's left. And so we're going to have it in the format of GCF times term 1 over GCF plus term 2 divided by GCF. That's just maybe a helpful way of thinking of what we're doing here. That's like really what factoring is. That's what's happening. So if we have our GCF is 2y minus 7, then our other factors is going to be these terms that are left in there. So we would have 5x plus 6y. We just write it just like we did before in the other video. In fact, I'm just going to pull down to that for a sec. So if we think back to here, we had this 4 was our GCF, and we pulled it out right here as a 4. A little laser. So we have our GCF, and then what was left was the x minus the 3. X minus 3, and that went right here inside the parentheses. It is a little awkward when our GCF is a binomial, but that's a legit thing. It's totally fine. Just got to get a little used to it. Now, one thing I want you to make sure of, there's no operation symbol in between here. I mean, maybe you could put a dot for times, but there's no plus or minus in there because this is a multiplier. So that's the same thing as what's happening with that binomial. Except when I pull out the GCF that's a binomial, I have to have parentheses. I could put parentheses around this 4, but I don't need to. But it's critical to do that for the binomial that's GCF. Okay, so now I went back to page 91. And again, I would just say right when you write this GCF or you're thinking of it, make sure, I would actually put it in parentheses right there from the get-go. Okay, you must have parentheses. GCF, if binomial. Okay. All right. So again, maybe stress that even more. And you might have more than, a couple of terms, but usually not. So now on this one, if you want to try for classwork, just pause and do for classwork, and then I'll show you, I'll go through it with you. Okay, so we have GCF is 2x plus 1. It's just like an apple. I have a common apple. I pull it out front. I write my apple in parentheses 2x plus 1, and then multiply by what's left, 3x minus 7. But make sure, again, put it in parentheses, no symbols in between other than maybe a dot, I think shows on some of the examples in my open mouse. All right, So hopefully that's coming together for you. It's a little weird at first, so just bear with it and try your best. So now we're going to look at 7.1.4, factor by grouping, steps for factoring by grouping. To factor by grouping, we first notice the polynomial expression obtains 4 terms. We can actually use this technique for trinomials as well. We can split apart the middle term, because you know how you have FOIL and you have those 2 like terms in the middle. We can split those back apart and we can use factor by grouping. So just keep that in the back of your mind when you're thinking about these. But whenever you have 4 terms like this and they're kind of all different stuff going on, you would definitely need to use factor by grouping. There's not another option to do the intuitive reverse FOIL that we'll do in the next video set. So we have 3ax minus 2a plus 15x minus 10. So we need to look at these separately first. So we're going to group 2 sets of terms. So we are going to have a symbol. We're going to have 2 binomials here separated by a plus. We're just using our associative property. So that's what we're doing first. We are putting parentheses around these. And then I'm going to pull out a common factor out of each one of these terms. So if I look here, I have 3ax minus 2a. What's common to both of them is just the a. So I write down the a. Then what's left in there is 3x minus 2. Now I bring down the plus. And then I pull out, I'm going to keep orange, another common term here, 15x minus 10. What's common to both of just these 2 terms is going to be 5. And what's left is 3x minus 2. And I have a match. That's kind of my goal, right? So that's my GCF right here is my GCF. Okay, so my GCF equals 3x minus 2. Remember, that comes out front, 3x minus 2. And now I don't put any symbol in, and I just write what's left. So what's in the orange here, a plus 5. And that would be my answer. And verifying it is a little tricky. You could, of course, just multiply those out, distribute. You would kind of be doing a FOIL thing. And you should get this back. But there is another way, if this is awkward to you to do this in sort of a horizontal format, we can actually use this area model. Sometimes people call it the box method. So I can draw a box and I can put all my terms in there. So I can write in, I'll put them in red, 3ax, and I actually can just put them in any order, minus 2a, but I usually just go kind of across like that, plus 15x, and then minus 10. And this is a positive also. I just usually put the signs there so that I am tracking, make sure I don't miss anything. Then I can look at each row, right? So I can look at this 3ax minus 2a, and I pull out what's common to that row, and I get an a. And then I can look again at this 15x minus 10, and I can pull out what's common to that row. And I pull out a 5. And again, it's a plus. So I want to put my symbol there. So you do have to watch for signs. Like if they were both negative, you would pull out a negative. And then I'm going to look at every column. So 3ax plus 15x, what's common to that would be 3x. And then I look at negative 2a and negative 10, and what's common to those, again, remember I said they're both negative, you want to put a minus, and then you would pull out the 2 would be common. And you can check these back because area model is length times width, right? So if these were dimensions, it would be this times that equals the box in the middle. So I would check back. A times 3x does in fact give me 3ax. A times negative 2 gives me negative 2a. 5 times 3x gives me my 15x. 5 times negative 2 gives me my negative 10. So now all I have to do is kind of stick some parentheses around these things, but don't leave it just like that. You want to rewrite it properly. A plus 5 times 3x minus 2. And you get the same answer. It's in a different order, which is fine because we have multiplication going on here, so it's commutative. So these are equivalent. Okay. So that is kind of a popular method to really, it's just about tracking. What's easier for you? Does this make more sense to you for tracking, and are you consistently correct? Even if it makes more sense tracking wise, but you're always getting problems wrong, maybe you want to try this one or vice versa. So I really don't mind which one, as long as you get the answer and you can show some kind of work is always important for me to see. And then, doing the check, do it off to the side here. I'll do the verifying. You would just do 3x times a would be 3xa. You would have 3x times 5 would be 15x. And you would have negative 2a. And you would have negative 10. And yes, if I, just reordered things, xa is the same as ax minus 2a. It's commutative as long as I take the sign with it. That's okay. Plus the 15x minus 10. And that is the same as what I started with. So it'd be good if you could pause the video, try this one for classwork. It is a little trickier because you have a sign to deal with in the middle. That's subtraction. So what I would suggest that you do right off the bat is change this to plus negative. And I think that will just make it work out better in the long run, because you're going to have to pull out a negative from there. So oftentimes that just helps people. If it doesn't and it messes you up, then no worries. Just ignore that. You can also put it in the box, remember? So if you're putting it all in the box, you would just write 6x squared minus 3x. And then again, that's a negative 4x. And then plus 2. I really find when you're first doing this, a lot of times the box is like a lifesaver for people. So go ahead and pause and try. So I'll go through both methods here, but first, when I'm doing by grouping, it's kind of like I'm putting this little, kind of line through here, and I'm dealing with these each separately at a time. I still have my operation symbol in the middle. And then I'm going to look at pulling out what's common to each of these two, the first two terms. If I can't find something common to the first two terms, I might need to rearrange things, which gets a little complicated. That's why the box, you don't ever have to rearrange. It works out really nicely. So I pull out a 3x, and then I'm left with an x minus, whoops, not an x, 2x. 2x, because I was thinking 3x times what gives me 6x squared. So 2x minus, and then 3x times 1 would be there. Don't forget about ones. I mean, it gets a little confusing sometimes. Then I'm going to write down my plus, and then I'm going to pull out a negative 2. Okay, so I have plus negative 2, and then what's left is 2 times, it would be 2x, and then a minus 1. So I had to pull out a negative 2 so that I would get a match here. That's my goal. I want a common factor. So I kind of had to force that. I mean, yes, I could have pulled out just a 2, but then I would have got negative 2x plus 1 in my parentheses. So if that happens and you don't quite have a match, you almost, but the signs are off, then just pull out the negative version instead. So then I have 3x minus 2 in parentheses times my GCF, which is 2x minus 1. Now remember, it doesn't really matter if that goes, first or second, the binomial for your GCF, it's fine. It's commutative. So if I did it with the box, if you got that and you want to move on, go for it. But with the box, I would pull out out of the row, I would have a 3x. Out of this second row, I would have a minus 2. Then again, I have to think like what's going to go up here and how it relates to the minus 2. So if I have a minus 2 here, what I want to pull out here would be positive so that this stays negative. So common to 6 and 4 would be a positive 2 and an x. And again, I'm picking positive because 2 times negative 2, I have to get that negative 4 back. Then look at this second column, minus 3x plus 2. There's nothing common, so I'm going to pull out a plus 1. There, but I have to make an adjustment here because in order to get this plus 2, this is why it's really important to check. I have to do negative 2 times negative 1 to get a positive 2, and I have to do negative 2 times 3x times negative 1 to get this negative 3x. So I have to actually pull out, write it like this, a plus negative 1. So that's why with the box method, the caution is just like here, you have to check it. You have to play with it and make sure you get your signs right. But you do get the same answer, 3x minus 2 times 2x minus 1. And they're equivalent. And I'll let you skip the verification on that. I don't often make you do those for these, maybe once on a quiz or something here and there. Okay, a couple more. We're on page 92. We're in example 7.10, factor by grouping. We have 12a squared minus 7b plus 3ab minus 28a. So if you're comfortable with it, you can do this one for classwork. If not, then just follow along with me. This one is kind of tricky. I think it's easiest if you write it as plus negative on each of these. So to do it by the just splitting it apart grouping method, I would stick some parentheses around these here and here. Then I would look what's common, 12a squared plus negative 7b. I have to look and see, nothing's working there for me. And then on this one, I only have an a that I could pull out. So what if I rearranged them? Let's try to rearrange instead. So I'm going to actually rewrite this because I can notice here 7 kind of goes good with 28 and 12 goes good with 3. So because of commutativity, I can pull them apart. So 12a squared plus 3ab. And that's one reason why I did that plus negative, so I can move stuff around and not lose my signs. So now I have the plus negative 7b and then the plus negative 28a. So those numbers are going to fit better for me to have something common. So now I put my parentheses here, and I can pull out of this one, I can pull out a 3a, and I would be left with 4a plus b. And then on this one, I can pull out a negative 7, and I will be left with a b plus 4a. Now I can rearrange this to be the same as 4a plus b. So I do have a common factor there, 4a plus b times 3a minus 7. That would be my answer. Now I will show it with the box. I'm not going to do it in video time, but I'll draw it out so that you can see the box. Okay, so I take back what I said earlier about like it doesn't really matter about when you plop the numbers in the box. It really does. You do have to be careful that they're going to line up. So I just want to make sure you want to make sure you set up your columns and rows where you're going to have something common to pull out. So I did 12a squared plus 3ab. So I knew I had some common pieces. And then the negative 28a and the minus 7b I put in the second row, and I switched these up. Here it didn't really affect so much which order because I was just pulling the 7 out, but here it has to match up. So I have to be able to pull out that 4a from the negative 28a as well, so that I can get everything back the way I needed. So you do get the same overall answer, 3a minus 7 times quantity 4a plus b, but you just have to be careful how you put the box. So if you're having trouble finding anything that factors out, or getting your multiplying back to get what you need in one of the boxes, then just try rearranging a little bit. Okay, so the last problem in this section, we're looking at example 7.11, and we have this note here: if the binomials are a minus b and b minus a, we factor out it's not a minus 1, it's factor out a negative 1 out of one of the binomials to obtain identical binomials. So if we have b minus a and we factor out a negative 1, we end up getting negative 1 times negative b plus a, which then allows us to rewrite it as negative 1 times a minus b. We can just then switch those. So just know that if you have a situation like this, you'll see later on, if you have something like this, a minus b over b minus a, that actually just reduces down to negative 1. And it's because we have a minus b over negative 1, a minus b. So you may see that later in the curriculum as well. One other way I like to write this is I would write b minus a as negative a plus b, and then negative 1 times a minus b. Okay, so those are equivalent methods, or maybe a different method to get to the same answer. That's what I should say. So example 7.11, factor by grouping. And this one we do have to rearrange a bit. So we're going to write 6xy minus 15y. Okay, so that's these two. Plus negative 8x plus 20. Okay, so now we can factor out a 3y here. And we end up with 2x minus 5 inside those parentheses, plus, and now we're going to factor out a negative 4, and we'll be left with 2x minus 5. So now we have 3y minus 4 times 2x minus 5. So we really didn't have to deal with anything along the lines of that note, but they had that there, so it may crop up later. So I hope that you have some patience just to practice through these. I know it's probably really a little different than something you've ever done. So if you want to email me, ask me questions, we can go over some things for sure. Let's do that. You have plenty of practice. I tried to make sure there was lots of videos to support you in the electronic homework as well. So have a great day.